Hello and welcome to yet another video of Cornerstones of Math. Today we are going to find the domain of this function with 4 logarithms, log base a of log base a of log base a of log base a of x. And I'm not just gonna solve this problem for the easy case where a is greater than 1. I will also tackle the case where a is greater than 0 and less than 1. But before we get to that interesting case, let us take care of the easier case first. The thing about logarithm is, the argument part of the logarithm must be positive. Therefore, for this composite function, every part that is inside the logarithm must be positive. This gives us the conditions such as these, and I am going to handle only this inequality because it gives the strictest condition for x. Because a is greater than 1, this inequality means that this part, log base a of log base a of x, is greater than 1. And this again means that this part, log base a of x, is greater than a, which again gives x is greater than a to the power of a. So this is the domain for the first case. And now the interesting one, when a is in between 0 and 1. We start the same. This inner part of the logarithm must be positive, so we have log base a of log base a of log base a of x is positive. But this is the point where things get different from the previous case. Now we are dealing with the case where a is greater than 0 and less than 1. As you can see, in this case, the graph is decreasing. Therefore, when we attempt to solve this kind of logarithmic inequality, the direction of the inequality sign must be changed whenever we reduce the logarithm. For example, if we have log base a of u is greater than 0 type of inequality, but when a is in between 0 and 1, this does not give u is greater than 1, because from the graph it is evident that the correct answer is u is greater than 0 and less than 1. So we have switched the direction of the inequality here, and we have additional u is greater than 0 because the logarithm can be only defined for positive u. So in our case, we have log base a of log base a of x is less than 1 here, and we have additional greater than 0. So now we have two inequalities. From log base a of log base a of x is greater than 0, again, when a is in between 0 and 1, we have log base a of x is greater than 0 and less than 1. And from log base a of log base a of x is less than 1, we have log base a of x is greater than a. So now we have two ranges for log base a of x. Since a is greater than 0 and less than 1, the common range is log base a of x is greater than a and less than 1. And we do the same thing again for these two inequalities. From log base a of x is greater than a, and let's actually write like this, we have x is less than a to the power of a, and we have additional greater than 0. And from log base a of x is less than 1, we have x is greater than a. So now we have these two ranges. Notice that this a is a to the power of 1. So here we use our knowledge of the graph of exponential functions y equals a to the power of x when a is greater than 0 and less than 1. In this case, we have decreasing graph. And from the graph, you can easily notice that a is greater than 0 and a to the power of a is greater than a. Therefore, the common range between these two is x is greater than a and less than a to the power of a. For example, when a equals 1/2, that is, for this function, the domain of this function is x is greater than 1/2 and less than 1/2 raised to the power of 1/2. Or you can write this as x is greater than 1/2 and less than 1/square root of 2, which you can easily check using the Desmos graphing calculator. And that's all for today's video. Thank you for watching, and I will see you in another video.